Hi, George.
Hi, Guillaume, and hi, everyone. Thank you for joining us as we come live to you. Apologies for being late. We had a bit of a technical glitch live streaming, but it seems that everything is in order and we're good to go. So, Guillaume, thank you for joining us, and yeah, thank you for making the time and the effort. And yeah, I think this first part of a three-part series is going to be pretty interesting. And in this part where we cover the sensor specifically, um, is where you would add a lot of value in terms of what you and the team have done at Dynamox. And yeah, it's a phenomenal product, and especially with the new release of the sensors. And as we go through comparing them to traditional way of taking these measurements.
Well, thanks, George. I'm happy to be here. And the first invitation you provided to us was about talking about sensors. But maybe as it's the first webinar we're doing. If you don't mind, I would like to briefly introduce Dynamox. Um, a bit of a story on who we are. I co-founded the company with my friend Alexander, and the interesting part is both of us are electrical engineer, and we come from the total different background. Alexander is very specialized in embedded system and software, whereas I did a master's degree in the US on ocean engineering with signal processing, and I did as well a PhD on mechanical engineering with signal processing and electronic devices for vibration control. So the company really was built on technical people, and I believe that's still our identity since then. And we, for a very long time, we struggled to find our own identity as a product, and we we always were oriented product, and we during almost 6 years we developed different type of products for different companies, and one day we identified a problem on the site where we were doing automation for a coffee cooperative, and we saw a guy risking his life trying to measure vibration of a bearing, and we asking why he didn't use its wireless sensors to do so, and that's how Dynamox was created. And we started. We actually, funny enough, we're the first company in the world to have actually commercialized a wireless sensor with temperature and vibration in 2015. Actually, we were using RFID system, and we saw the people really getting very excited. And as soon as they saw the price of the sensor, they were really happy. But when they saw the price of the RFID collector, they really was impressed in terms of prices. So we actually the people wanted to use our system, and we couldn't actually popularize the RFID collector. So we did a huge introspection, and we tried to understand what they had in hand, and they had always cell phone, and we actually tried to see what cell phone could provide us wireless communication, but with low energy consumption for the data logger. And the NFC is too close, so in terms of safety, that would be a problem. The Wi-Fi didn't have at the time low energy consumption design, and so we come up with Bluetooth low energy design, and we are starting from it. And it's very the identity of the company is very strong, so we're very technically oriented, and we started to totally reverse to what the world was doing, because most of the other company believe that the Chinese would actually provide the hardware, and so they focused on the software, whereas we saw that there was something to it that was slightly different, and we understand that the market wasn't what the other people believe were, and we actually focused on the hardware instead of the software at the very beginning. So we ended up with having one of the first low energy, Bluetooth low energy vibration and temperature sensors at the time. And in order to, when we actually were bringing the sensor to the company, they said, okay, we do have a sensor, and now what? So we succeeded to find partners. One in pulp and paper, which is Klabin. The other one in mine industry, which is Vale, one of the biggest mining industry. And during almost 3 years, we listened to them and see how they could use and how they could perform with the wireless sensor, but as well how we could actually bring something to the table different to the other big players. And that's where the identity of the company really started. And that's where we actually saw that Dynamox is really building a partnership, and it's not about selling the sensor, but understand where the maturity of the company is, and then going forwards toward the predictive maintenance and the reliability. And so far, that's brought us up to Australia and knowing you, and we're really pleased with that, actually.
Yeah, no, good. Thanks for the feedback on and the history. It's always interesting to find out where a company evolves from and where you start from. You've obviously, with the collaboration and with the partnerships that you've built with Vale and with the paper mill, you're now into what I believe is probably the second generation or a new generation of sensors that you've released to the market. And with this, obviously, comes a lot of how can you say a lot of work and a lot of how can you say development within your company. If you can explain to us briefly, just having a look at this slide that you're about to present. At Dynamox, what makes you different, and how do you develop these sensors and the software? Do you do it in-house? Is everything come from your factory in Brazil?
Yes, that indeed, actually. First of all, currently we're in 15 to 18 countries, and it's important to mention that we within the company we have 230 people so far. And the very characteristic of our company is, as I was mentioning before, we're a tech company, so we do have like lots of engineers, technician, postgrad, PhD, master's degree. So almost 100 people in a company are focused on developing the hardware, the software, integrating the solution. So we really take into account what we believe is the pain of the clients, and we're not becoming slave of the client. We're actually understanding this pain and transforming it to a more generated product. And that's what I believe it's a differential from our company to other company, where the big company comes, they have an amazing software, but they say, here is our software, use it as such. If you do have a problem, that's because you don't understand. And I believe now with Industry 4.0, it is slightly different. The big company is starting to have a better understanding what needs to be done and the efficiency of it. And that's where we actually have created a methodology to understand the clients, to be able to customize the solution for them, and evolving with them in terms of understanding how far we can get in terms of performance and reducing the downtime of the sensors of the assets. Actually, mentioning the company, we indeed a hardware and a software company. There is a lot of challenging to that, because you really have to combine the understanding of the hardware, the production line, and making sure that is actually fully combined with our software and the identity of the company. So
No, thanks for that. I think one of the key factors, one of the things that drew me to Dynamox is that you're a company that started by sorry, developing a product and then moved it up and just made it better. I've seen the evolution of the original sensor to where you are now. It's a company that is really easy to deal with and very agile. You know, you really do listen to what the customer says. Even some of the requests that we've put through from the Australian market, and really the way that the team has listened to what we've asked and given us what we need. You know, just a simple thing as a dashboard. You know, being able to visualize what you're actually seeing out in the field from your office. Just the simple things like that that really, you know, where hardware and software come together and visualize that for the customer. I think that is something that you've done really, really well.
Yes, thanks. One thing is important to understand is how the company has structured itself. So one of the main industry we're operating in is oil and gas, mining, agribusiness, pulp and paper, and we in this field we actually succeeded to have the main monitoring of vibration screen, electrical motors, all the classical one, but as well crushers, millers, train. So we actually fully diversified ourselves, but always based on the technological parts, and that come up as well with another worry we have is how the clients could see us and that he can see that we worried about what we do with this data. So we decided to go ahead and apply for the certification, and one is the process one, which is ISO 9001 for the production line, and the entire other ones, which is the family of the ISO 27, is from the protection, privacy, and security data of the clients. And so far, from what I know, we are one of the only company on the market on these fields to have those three certification. We just actually been recommended by Bureau Veritas last week on 27701 and 018, which is on the privacy on the cloud as well. One of the things I wanted to say as well, we're now answering to some of our very big clients. So the worry is how we could be compliant with those clients, how we could actually show them that we with them, and how we could improve their own actually system to make sure they as well are attending their own compliance. So we really worked hard on that. And one of the thing that came across is Metso Outotec noticed that, and we actually built up a partnership with them worldwide to collaborate on telemetrical parts of. We're starting with the vibration screen. Today, we're one of the only company in the world be able to monitor properly with wireless sensor. We know that wired sensors on the vibration screen doesn't stand for a very long time, and with Metso, we build up a collaboration to higher the level of telemetrical solution, complex solution for mineral solution and aggregates. And so now we really moving forward together. We two separate companies, but we providing the telemetrical part of it, and that's make the able to monitor the assets in a fully different ways and adding value to the end clients as well. One of the other thing as well I wanted to mention. Sorry, go ahead, George.
Just going on to that Metso collaboration.
Yeah.
Obviously, vibration screens are probably one of the most challenging and most difficult applications, I firmly believe, out there to measure vibration on, just due to the complexity and everything that goes on around a screen. So I know that we'll get into the sensor shortly, but just quickly from your point, to be able to monitor a screen, there's probably a couple of key aspects that you have to have in place to be able to do it successfully. Is there some feedback that you can give us on that?
Yes, I mean it's a combination of three things. You have amazing professional, as I mentioned. We had a team that's actually study and fully understand on knowledgeable on vibration. We do have a software which is ergonomic and bring the data in a way that the end user can actually take measures according to what we provide, and the high quality of the sensors as well allowed that. So the combination of the three really allowed to bring this reality to the end user, and that's why I'm insisting on the fact that we're building partnerships. So it's exactly what we created with Metso. We took the best of the two worlds, the understanding on the mechanical part and our understanding on the telemetrical part. We gathered that to offer that to the end clients actually. And if you don't mind, I would like to actually get a bit more into the sensor part. And before that, I know it's a pain in the ass talking a bit about theory and stuff, but I think nobody's going to die if we do a bit of theory before going to the sensors part.
Absolutely.
When we talk about measurements and Fourier transform, there is a concept that needs to be understood. So, for instance, when you have a sample frequency, the sample frequency defines the frequency range. And when you have an acquisition time, you define the frequency resolution of your system, of the spectral analysis, and the dynamic range, which is the height, is actually versus the resolution. So all those features combined needs to be taken into account to starting evaluating how good is your sensor. The other concept is if you want to move from a time series up to a frequency series, a spectral space, you need to have frequency response as flat as possible. So in order to know if you have a good sensor, the proper way of doing it is looking at is a response frequency response and how it's relevant. So the question that needs to be answered is how flat is the frequency response? Up to when my frequency response is flat, because beside that, that would depend of the resolution I have, how my frequency response is decaying as well, how fast it is to avoid aliasing, for instance. Up to when is the measurement valid? Because if not, you need to chop it off. And when the ripple of my frequency response is having an impact of my frequency response, all those questions would actually be able to attend and be careful on what sensors to look at actually. And to me, to look at what's the right sensor, you have to answer 4 questions. Is the sensor characteristic by itself enough? So we were going to look at that. How the analog sensor signal is converted to digital in order to process the fast Fourier transform. Is the sensor fixation relevant? And what is the level of spectral electrical noise within the measurement system? Because if all your electrical noise is covering the interesting signal, you actually can't analyze anything. So looking at more sensors, if you're looking at the frequency response of, if you don't mind, everything we're going to talk to going to be based on high quality sensors, okay? Yep. So looking at a piezo sensor high quality, you can see that the resonant frequency can be very high up, go up to 20 kilohertz, and even more in some cases. If you look at a high quality MEMS capacitive sensor, you can see that it's flatter on the very beginning, and it doesn't have a resonance frequency, and it usually go up to let's say 8 to 10 kilohertz, the best ones. Now, if you look at the sensor fixation, so based on on the fixation you have, you would go from high frequency to the lowest frequency. So if you have a stud, it would go up to 20 kilohertz. If you have an adhesive, it would go slightly below. An adhesive like epox, something, it would go even below. A flat or pole magnet, it would go even below, and a probe, that would really go below. So if you look at it, if you have a magnet, the highest frequency you actually be able to measure would be 5, the maximum in terms of kilohertz, 5 to 6 kilohertz. And
just on that one, Guillaume, if we could just go back there. This is something that I've seen a lot in the field, is that people are using magnetic pads and using magnets for fixation, for fixing a quick way of fixing a vibration sensor to a piece of equipment. So typically what you're saying here is that a magnet's obviously not the best way to go.
Yeah, the magnet would make your frequency response drop drastically after. Even there is some magnets that even cuts the frequency at 2 kilohertz actually. So it is something that's really needs to be addressed. The magnet has an enormous impact on the measurement actually.
Thanks for clarifying that. Thank you.
So in terms of spectral noise level, comparing high quality MEMS with piezo, you could see definitely that MEMS, as the electronic is all embedded, the spectral noise is slightly higher. And if you look at the analogical digital converter, you really need to look at it in a different way. If you look at a data logger, everything is embedded within the MEMS sensor. Whereas when you have a typical collector or a gateway, you have the piezo, you have the cable, and you have an entire structure that would actually convert that to a digital to analog to digital converter. So you could have a better resolution, but in some extent, MEMS today has a very great resolution as well, from 20 to 16 bits, actually, we're talking. So making a conclusion here, if you, it doesn't really matter if you have an amazing sensor going to hundreds and kilohertz if you're using the wrong fixation, like as you exactly said. If you have a new magnetic base, that would drop off. Definitely your resolution and how you look at the condition-based monitoring. So if you look at this frequency range, you can see that the range of interest go up to 6 to 8 kilohertz max, where actually data loggers with really good quality MEMS covered this frequency range. And using high quality digital analog to digital converter, you actually be able to cover fully this range. So in terms of really addressing a short conclusion to that, the fixation defines really the frequency range. It is as well important to understand what you're after in the acquisition system. And the sensor itself is just part of the acquisition system, but it's not all of it. And a good rule of thumb, and if your offline collector did the job, a data logger with MEMS capacitive does it just as well. What I meant by that is today's, at least I'm in Dynamox, our data logger using the best performing MEMS on the market, and we're able to actually be even better than the offline collector system due to the magnetic base and so on I mentioned. A slight tip I wanted to say is you shouldn't ask anymore if the sensor is piezo or MEMS, but because you could have actually a MEMS which is piezo. A MEMS is it's a process of fabrication. It's a process of fabrication microcontroller. So that would be more the difference with is, do you using a piezo or a capacitive sensor, and afterwards what is the process of fabrication? So if it's MEMS, that would be the same thing as microcontroller. So that's I believe that was just a tip on the sensor part. Going a bit more on the type of sensors, if you want to go wired or wireless, in terms of infrastructure and installation, the wired, due to cabling infrastructure, is much heavier than actually the wireless one. In terms of cost, obviously, it's much higher. In the other hand, supposedly you have a much higher lifetime that's a wireless sensor, which today go from 3 to 5 years time, actually. In terms of maintenance, you do have an enormous cost in terms of wired cable in that part. And when you're on the wireless one, you just have to dismantle the wireless sensor and just replace it. On the scalability of it, you need more infrastructure involved, of course. And whereas if you already have the gateway, it's just a matter of actually putting more sensors. In terms of security, this is an interesting part. For a very long time, people believed that wired was the highest standards, whereas today, wireless is the highest standards as well. It's just a matter of process, and that's why the certification is really important. And in terms of range, again, your infrastructure is dependent when you're talking about the wired. And for the wireless, you can place it anywhere in the reach of the wireless gateway, actually. So at the end of the day, there is no miracle solution to that.
Thanks for that comparison, Guillaume. We've actually just yesterday speaking to a new customer about a wired solution versus a wireless solution, and when we spoke about the price of and the ease of installation,
Yeah.
for him it was, wow, that is really going to be a simpler way of doing things. And just one step further on that, wireless versus wireless, doing a field trial. This is what we find a lot with a lot of new customers, is to prove the concept of wireless technology and how good it is and how quickly it is to implement. If we know what we're gonna do and where we're gonna set it up, the actual installation time could be basically 2 hours, simple time, just 2 hours, install the sensors, plug in the gateway, and give it a trial. And this is what I think personally has amazed a lot of customers, is how quick and easy it is to implement a wireless system for a trial. So yeah, nice one. Thank you.
In terms of so in the wireless world, there is two versions. One is one fits all sensor versus a use specific sensor. And I try to make a table and see the one fits all sensor, and I couldn't, because in terms of size, when you have several different sensors that's to be used, that's always going to be much smaller. In terms of cost, of course, it's going to be much higher. And in terms of lifetime, as it does everything, you would have a much shorter lifetime. So I don't see any advantages of having one fits all sensor. It's much less cost effective, actually. In terms of why Dynamox went to Bluetooth sensors, it's always a compromise. So you have to look at the range, the data rates, which is important, because as we're doing a lot of spectral analysis, we need a certain number of points in our time series. The power consumption is very important, the size of the sensor, because you could see a very nice sensor and there is actually an antenna to it, and people have a game to break the antenna, and you can't actually do it. You can actually use it anymore. In terms of security, the Bluetooth has encrypted data as well. The compatibility with bandwidth available on the field, we actually find out that's a lot of companies using Wi-Fi, and all the bands are already packed. So we can actually use the Wi-Fi on the sites. And in terms of prices. So what we did is we combined the best worlds. We combined the best of the two worlds. So the Bluetooth Low Energy 5.3, which is really amazing in terms of range, in terms of everything, and we couple it with the gateway. We could be 4G, LTE, Wi-Fi, or Ethernet choice to the customers, actually. So when we talk about wireless, a lot of things come up, and it is what guarantee the quality and the cybersecurity of it. And the answer to that is certification. It is important to mention that ISO 27001 family is fully different to any other ISO certification, because it actually puts the bar that you have 114 controls on everything that needs to be done. So it is really important to understand, if you don't reach any of one of those control, you're actually out of the game. So go ahead.
Yeah,
Yes.
just on that, Guillaume, I think getting your ISO certification, especially 27001, what was the most challenging aspect of getting this? Because as you said, it's not just ticking boxes. It's you have to go into the nuts and bolts of your organization to get that one.
The hardest part was actually making sure that the 114 controls attend the highest standards, because we're not talking just software. We're actually talking about cryptography. We're talking about human resources, asset control, operations. We're talking about all those bullet points that need to be answered and actually discursively answered, and that's going to be checked by the auditor. So it's really important to understand this part. So I think in terms of how the clients, the end user, can actually judge the quality of the manufacturer or the solution provider, certification. So yes, certification really does matter, and I believe that's one of the main points, actually.
Absolutely.
One of the points, if you don't mind, is, as again, going back to the fact we very technical, we decided early on to save the raw waveform. So saving the raw waveform allowed us to post-process the data, put triaxial band alarm setup, see the transients evolution of the signal, and we really able to master some of signal processing filtering, like envelope that customized frequency with customized frequency interval, with suggested interval for depending of the failure type of failure you want to look at, or the equipment you want to look at. So it is really important for us to have the waveform. I know it's really nerd to say that, but it was important to us since the beginning to provide always the best to the end client.
Very good. That's a question we've received quite a bit, because you now give the customers the ability to go in and customize them for themselves, which is
Exactly.
with the post processing. Yeah, very, very good.
And as well, if you look at it, you can actually, as a software is a continuous improvement, you can always come back to a year ago data, and actually process with the new senior processing tool, and you would see the difference in terms of processing. So now you're going to the sensor generation, the new generation we have. So I can actually introduce you to the TCH, to the TCHG, which is measuring global data. So it's really good for bus bar, for if you want to measure wagon axis, if you want to use idlers, vibration. It is really interesting on that part. It's very small and very convenient to just glue. You do have the TCAS, which has the same feature as the TCAG, but you can actually as well do spectral analysis or waveform analysis on it. It go up to 5 kilohertz of sample frequency. So the spectral maximum frequency would be 2.5 kilohertz, actually.
So Guillaume,
And
sorry, just going back to the TCAG. So
yes,
you developed a sensor that can measure global vibration and temperature, and it is a very cost-effective way of doing it. So You mentioned buzz bars there, where a customer could even put this in an MCC or a cold room or something like that, or even in an electrical panel, just to measure the ambient temperature there and capture the data. Because having a chat with a customer yesterday up in the Pilbara, there's a bit of a heat wave going through, and he mentioned, 45, 50 degrees, outside. So having a sensor like this in an electrical panel would give you the ability to wirelessly log the data, go back with your phone, extract the data, know what the temperature was in that panel over that time, or automate the solution through a gateway and know what the temperature is inside your MCC from the comfort of your desk. Is that how simple it is just with this?
It is as simple as it is. You could use either the smartphone or the gateway if you want to automate. But really, it's as simple. We designed that to make it the simplest possible and accessible in terms of money wise. So you can scale it as much as you can, as you want actually.
Good to hear.
So
No, thank you.
if you look at those sensors, both have up to 5 years lifetime in a very standard way of using it. You can have 120 meters in the free field in terms of range. So it is a different ball game with this new generation of Bluetooth Low Energy 5.3 protocol. And we do have the HF Plus, which is go up to 26 kilohertz of sample frequency, which means you could go up to a spectral max frequency analysis of 13 kilohertz. All the sensors are IP66, IP68, and anti-explosive zone 0 and 20 as well. So they all have a purpose to it. So you could typically use the TCS for the vibration screen spring. You could use it on more simple motors and so on, whereas the HF could take the end spectrum of it. So it would go to very high frequency and it could go to ultra low frequency. So anything that have 2, 4, 5 RPM, you would be able to measure, because we are able to actually measure up to 3 minutes of time series with them, reducing the sample frequency of it.
So just one quick question on this though.
Yeah.
So we were talking about the traditional way of taking the measurement in the field, where Dynamox started seeing the safety factor of people going into the field around rotating equipment and taking a measurement. And it's evolved from there to this sensor now, this generation of sensor, that you could basically grab the data every minute. You could grab the data and you could basically then store it inside the sensor and then upload it, and the customer can visualize it from his desk. So it really has evolved from a safety aspect, but now also from a technology aspect, and the ability to measure that frequency and to have that much resolution. It is really mind blowing what you guys have developed.
Yeah. No, I'm very proud of the team. There is one thing as well we worried about is be able to update the firmware remotely. So continuously, we would actually improve the firmware in order to put some more features into it. So really, it's really a game changer in terms of the censored wireless sensors data loggers actually. Maybe, George, I was very going through why Dynamox in terms of web platform and tools and so on, but I believe this would be a new webinar that could be developed to expose what tools we're using and so on. And I would maybe very shortly show 2 success cases on vibration screen and motor pump very briefly. So in terms of vibration screen, we have entire dashboards developed in collaboration with Metso, which has an enormous understanding in vibration screen as well, to make sure that you have a very healthy vibration screen. And we go up to the prescriptive part of it, looking at the orbits. And one of the success cases, we took a bearing exciter bearing failure with which we actually identify it. We could look at the performance, looking at the orbital as well. And in terms of motor pump, it's the same. We have automatic detection failure system that actually pinpoint where the failure potentially would be, and to help the customers to actually be able to go directly on the problem. You need to make the system work for you, and we're able to actually do that with our different system and using our own tools. A typical example here is we're able to pick up cavitation. We do have several different examples, and I believe we could actually talk about that in a different webinar. There is several success cases on LinkedIn published on our webpage as well. And we could actually talk about integrating the solution into any third-party software like ERP system, like SAP, or any management system like OZSoft, PI Vision type of things. So, but for today, I believe I extended my time. My apologies for that. And that was the first time. I'm gonna policize myself better next time, actually. So if anybody have any question, please fire up, actually.
Yeah, you can put your questions into the comments section on the webinar, and yeah, let us know your questions. And also maybe a good time to discuss the second webinars, where as Guillaume mentioned, where we would like to do a next one where we go into the software. Having the sensor is one part, and Guillaume said there's 3 different aspects to monitoring screens. One is having a good sensor. The next is having the software, to show you what the sensor is actually measuring. And then the third part is the integration and the dashboards, visualization for management or for anybody to have a look at what's physically going on in the field, similar to what was on your screen before.
And if you allow me as well, so we started at a vibration temperature company, and now we see that our solution can unify the predictive maintenance and feeding the reliability centers as well. So we as well will have current and voltage sensors that would be within our solution to actually coupled with our automatic diagnosis to perform to the end clients as well. So the idea is to unify those data to put more intelligence to the system, for the system to work for the end user, actually.
Yeah, no, absolutely. I think the value is of the system is purely visualization. The end user has to see the benefit of using an online vibration system, and
yeah.
You've seen it in your partnership with Barrault, where they've implemented. Maybe you could just give us a brief overview of that. Is where they've gone from being your testing ground to test these sensors in the harshest conditions out there. And that partnership evolving into something really special, where they've actually implemented a full system. Maybe if you could give us a few minutes, just explain that to us.
Yes, we really literally started as a sensor provider for them, and we're evolving to putting sensors in different. Everywhere they had difficulty to measure and it was a safety issue, we put sensors, and we actually created and added value to that. So now any equipment which is quite complex, we really are able to deliver a better understanding than any other people on the markets that's doing the same thing as we do, actually, because we're forced at the very beginning to take the more complex equipment. So we actually build our understanding on that. So vibration screen was one of the first of it. The driving parts of the conveyor belt, crusher, millers, motor pump. We even have how they call it, the centrifugus parts. Anything that is really idlers to the conveyor belt, anything that's were really difficult to access, we actually were able to extract value. off-road vehicles as well. Unbelievably enough, we able to help on equipment which is such already highly monitored. So
yeah, very interesting. Guillaume, there's a question that's come through from Isaac. Thank you, Isaac. Are we planning on going for temperatures higher than 90 degrees with the sensors?
yes, there is. It's on the roadmap for next year. We would have a solution with attend upper than 90 degrees. So we will be able to attend this market as well, because it is actually a pain for the customers. And the really problem is not so much that we cannot do it, it's the electronic limitation of it. So we're currently working on it. We already have a very good understanding what needs to be done, and it's already been designed by the hardware team. So yeah, we will have a solution for that actually.
Thank you. I had a question.
Yeah.
I had a question for you with regards to the HF and the HF plus sensor. You know, you've developed a sensor that is technically, excuse me, but in a way twice as good as the initial one. But the price point that you've put it to the market is at the same price as what you had your initial sensor out there for. Can you explain that to us? Because that's really, going against what the market would typically do.
That's where we had a very strong discussion on that. Should we actually raise the price as the electronic increase, as everything increase? And we believe that wouldn't be fair. And we worked on be more efficient on the way we're doing it. We believe that if the clients can see the added value to the sensor, we would gain in terms of scale, and we would actually be able to as well manage to put even more value from the software to the prescription to automatic detection failure sensor. So we really decided to go against the market, to make a statement to say, okay, we will build a partnership. And one of the first thing is we understand that the price it could be an issue to scale up, and we want to help on that. So that's why we actually decided to not increase the price actually on the HF Plus sensor. And I can tell you, the HF Plus, we could do another webinar on what's going on the HF Plus, because it would be able to separate the high frequency RMS from the low frequency RMS in the continuous measurement. So you do have the continuous measurement, and then you do have the spectral analysis measurement. And by doing that, just by the continuous measurement, you would be able to actually see already a trend of type of failure that's happening into the assets. So it's really totally different technology, but we decided to really hear what our clients and partners are saying and make the efforts on our sides to show that the partnership starts with us as well.
Yeah, it's phenomenal. It's really good. Thank you. There's one more question that's come through, Guillaume. The trucks in the miner are monitoring the pumps of oil, but the temperature that the device came to up acceleration and heating the sensor and open. Okay, so yeah, had a challenge that the temperature went above the limitation by the sounds of things.
Yeah, I mean, it's if you look at I can understand that sometimes it's all about compromise. So if you have a problem and you see that your equipment is above what is the data sheet is suggesting, you could go on it, but you know that the sensor wouldn't last for very long. But at the same time, if it allowed you to identify where is the problem, it was worth doing it. And so in his case, sometimes it is actually worth doing it. We have clients that do have enormous problem with high heat places, and they do put the sensor knowing that it's going to fry, but just in order to actually see what the problem is, and then to analyze it for a few days actually.
So basically a risk versus reward scenario where you sacrifice the sensor to know what's going on in the field.
Yes.
Yep.
In terms of integration, yes, we are integrated with SAP actually. We are able to communicate directly with SAP. It is important to mention that we do have a solution that's coupled fully with our predictive solution, which is the sensitive part. So by actually, when you do have automatic detection system, you need to have a feedback from the field. So having a sensitive part, which is a sort of a checklist for the maintenance routes, that allowed you to see that if your algorithm are picking up the correct failure, and you can feed it, and as well by cross-referencing the sensitive with the predictive, you get more efficiency. So going back to the SAP thing, we do work with SAP. We do work with any ERP system that is on the market. It's just a matter of having the right API, or even as well low level system like MES system or MES system. We're able to be fully integrated with those system, and even more, we could process the data, provide the alarm, and send the alarm to the third parts system, and trigger a service order or a maintenance order into a sensitive software to do the root maintenance and actually close the service order. So we actually have the entire loop being designed for that.
Yeah, I think what you bring to the party there is something unique on its own, and I think the sensitive inspection is one that you could cover in a webinar on its own, because I was really surprised to see that you have up to 27,000 reports going into that thing daily. You know, people going to do their inspections out in the field, listening, being able to take recordings of machines, take photos. Drop down menus where you can tick that you've seen something's wrong with a conveyor, or you can hear that an idler is screaming or something like that. I think that in its own should is a topic for discussion. So
yes.
they're really, really good. No, well, it looks like we've run out of time, and apologies once again to everybody for the delay in starting up. Thanks to you, Guillaume, for taking the time and the effort to have this chat with us and talk about the sensors. And I think the highlight for me is what you've discussed today is the fixation, the mounting. Using a magnet, using a point, or using a screw to detect it. That has a lot to do with what the capability of the instrument, the sensor itself can actually measure. So that's a good takeaway point for me specifically, but for our customers too, I believe.
Yeah, well, thank you very much for your invitation. I will be in Australia in Perth more specifically. So if anyone wants to go in more details on a solution, I would be happy with George to attend more specific needs. It is important to understand that today company shouldn't buy what's the provider is providing now, but what the providers will provide now and develop in the next 3 years. And as well, it is important to have a knowledge that's what's the manufacturer or the provider solution, how is his understanding. So I think what we put on the table here is that we understanding vibration, we understanding hardware, we understanding the software, and we understanding the process, the maintenance process, and the reliability levels that need to be in the highest quality possible for the company. So to me, it's a pleasure to be with you, George. Thank you very much for the invite, and it would be a pleasure to see you in Australia. And maybe in Australia we could do a second webinar with even more competent people to talk about the platform or the integration, because I can talk about software and hardware in a more generic way, but there is people who are specialized in the company, and I believe that would be more appropriate for a more technical audience, actually.
Very good. Thank you very much. We look forward to meeting you here in Australia. And as Guillaume mentioned, he'll be in Perth beginning of January, or for the month of January, essentially. And we look forward to catching up with you. Yep. Thank you very much, everybody. And apologies that we were late once again. Take care.
Bye. Ciao, ciao.